A 5 kilogram box moving at 2 meters per second collides elastically with a 3 kilogram crate moving in the opposite direction at 4 meters per second. After the collision, the 5 kilogram box bounces off at 2.5 meters per second in the opposite direction. What is the speed of the crate after the collision? For any type of collision, we know that momentum is conserved. So that means the initial momentum, Pi, of the system, both masses together, has to equal the final momentum of the system, or Pf. So we go ahead and set up our total equation here. So we got the mass of the box times velocity of the box initially, plus mass of the crate times velocity of the crate initially, equals the final momentum of the box plus the final momentum of the crate. Now for these momentum problems, it's important to denote direction. So I'm going to denote the positive when the box is moving or crate is moving to the right, and the negative velocity when the box or crate is moving to the left. So initially on the left side of our equation, we got 5 kilograms times 2 meters per second for the box, plus 3 kilograms times negative 4 meters per second for the crate. And again, the negative because that crate is moving to the left. So when we go ahead and plug in our numbers and do our math, we see that the total momentum of the system initially, which is the same as the final momentum, is negative 2 kilogram meters per second. On the right side of the equation, or the final momentum, we have mass, 5 kilograms times negative 2.5 meters per second, because the 5 kilogram box bounces off in the opposite direction, is now moving to the left, plus the momentum of the crate, 3 kilograms times its velocity, which is what we were trying to solve for. And when we go ahead and multiply 5 times negative 2.5, we get negative 12.5. And we are left with 3 times VC. And after we do our math and solve, we see that the final velocity of the crate is equal to 3.5 meters per second. And it comes out to be positive, which means that the crate is moving to the right after it bounces off elastically. Now we're done with the problem, but let's ask ourselves, is energy conserved for an elastic collision? So when two things collide in a perfectly 100% elastic collision, is energy conserved? When discussing energy in this type of problem, really the only energy that is present is the kinetic energy. So conservation of energy, this idea of conservation of energy, the energy initial, so the two kinetic energies from both masses, equals the total kinetic energy from the two masses after the collision. And that's the idea, and that's what we're trying to see, if the left side of the equation in fact equals the right side of the equation. So initially we have the 5 kilogram mass moving at 2 meters per second, so we plug that in, 1/2 mv squared, and the crate, 1/2 3 kilograms times negative 4 meters per second because it was moving to the left. Now as we see, because it's squared anyways, then negative actually doesn't really matter at all. So when we go ahead and plug this into our calculator, the left side of the equation equals 34 joules. Now for the right side of the equation, we got the mass, 5 kilograms, 1/2 5 times negative 2.5, again bouncing to the left, but that doesn't matter. It's going to come out to be positive because it's negative 2.5 squared. And the crate, 3 kilograms times the velocity, which we had just solved for, 3.5 meters per second. Again, square that as well, and we see that the right side of the equation also is 34 joules. So clearly these two numbers are equal to each other, so therefore, yes, energy is conserved for an elastic collision, and only an elastic collision.